when you're ready.
Right. So my question is, how can we use vermicomposting to most effectively help grow Minnesota crops? So vermicomposting is the process of utilizing worms to convert organic material to fertilizer. And in a traditional compost, you use solely microorganisms, but in a vermicompost you use worms and microorganisms, and this helps the process go faster and it adds more nutrients back into the fertilizer you make. Okay, and in a typical vermicomposting bin, you have two types of organic materials, which are green materials and brown materials. And in a usual bin, you have an equal number of both. But in my study, I wanted to identify the specific physical and chemical properties that the different materials had to the castings. So I split them up into a group that only did green materials, a group that only did brown materials, and a group that did both as my control group. And by deepening this understanding, we can curate a specific combo of organic materials so we replenish the soil and most effectively promote growth. So for my bin procedure, I took three 10-quart storage containers and I drilled holes into the sides and the lids, and I filled it up about a fourth up with soil. And I distributed an equal amount of worms in each bin. There was probably about 150 red wiggler worms. And then I labeled the bins green, brown, and control based on what materials they were gonna get, and then I stored them in a dark place. So the materials, I researched like common materials that I had around my house that I could give to them and what nutrients they added back into the compost. And for my green materials list, I decided to use eggshells, apples, broccoli, potato skins, cucumber, carrots, and bell peppers. And for the brown materials, I used coffee grounds, green tea bags, newspapers, leaves and twigs, paper towels, egg cartons, and hay. And I fed them for a 60-day period, and they were fed every 5 days, and I noted down the material given, the amounts, and any observations. And this is the data table for the green bin. And as you can see on day 25 and 50, on observations I put drained worm tea, and then on the 25th I laid down some newspaper. And then in the brown table group, I started adding a half a cup of water on the 20th and continued it every other feeding day until the 50th, because I noticed that it was getting pretty dry. And so I drained the worm tea, which is what they call the excess liquid left in the vermicomposting process, every 25 days, and I laid down newspaper to keep the moisture levels regulated, because moisture is very important in a vermicomposting bin. The worms breathe through their skin, and they need a lot of moisture in the soil so that they can be covered in this mucus that allows like their pores to absorb the air. So if it's too dry, they'll suffocate like they started doing in my brown bin, and if it's too wet, they'll start drowning like they did in my green bin. And before I started regulating the moisture, I noticed that the worms were dying and they were acting more lethargic, and as I continued and started making the small adjustments to adjust the moisture, they started thriving more. And then after 60 days, the castings were separated from the soil, and the process of this is you flip the bin over so that the bottom is now on the top, and the bottom is where you typically leave the castings and the worms congregate. And then you shine a bright light, and the worms are photophobic, so they burrow deeper into the soil, and then you can scrape the top layer, which is all castings, off, and it's just the easiest way to get the castings. And then the first things I did was observe the physical qualities. There was a lot of similarities in all three of the bins, but the biggest differences came in the moisture, the smell, and the color. So for the green bin, it was very high moisture, it was pretty pungent smelling, and it was a darkest reddish brown. For the control group, it was the moisture was normal, it was a little bit odorous, and it was pretty much the same color as the green. And for the brown, it was pretty dry, there was little to no smell, and it was a dark browny black and had a little bit less red than the other two. So then I decided to test them for the chemical properties, and before I started knowing what to test them for, I reanalyzed the nutrients that I added in the materials and what they added into the soil. And I found that a lot of the green materials I added a lot of potassium, while the brown added nitrogen and phosphorus. So I decided to test for nitrogen and phosphorus, and then I threw in pH just to see if it was different. So I gathered some samples from each of the bins and I dried them out, and then I tested for pH first. I would take a milliliter of the sample and then add a scoop of barium sulfate, and then I added pH solution until it reached the 2.5 milliliter mark, and then I shook it for 5 minutes, and then after the 5 minutes I would analyze it and compare it to the guide that was given in the soil test kit. And then for the nitrogen test, I added 1 milliliter of soil, and I filtered this with 1.5 milliliters of nitrate extractant solution, and I filtered it until I had a liquid. And then I took the filtered solution and I scooped nitrate reactant powder into it, and I shook it for 10 seconds and then let it sit. And then after 5 minutes, I compared it to the guide given in the kit. And I repeated this for both the potassium and the phosphorus using the appropriate extractant solutions and reactant powders. And I tested each of the bins samples 3 times to ensure there was no error. So for the data I got, for the green bin, the pH levels were 7.5. It was deficient in both nitrogen and phosphorus and sufficient in potassium. The brown bin had a pH of 7.4. It was surplus in nitrogen, sufficient in phosphorus, and adequate in potassium. And for the control group, it had a pH of 7.5, adequate levels of nitrogen, and sufficient levels of both phosphorus and potassium. So I decided to apply this to what growing something in Minnesota would be like. So in the Hennepin County, we mostly have alpha soils, which is a type of soil that is a subsurface layer of clay, and then it has a saturated base soil. And these are rich in calcium, magnesium, potassium, and sodium, and it makes it very effective in growing vegetation, especially ones that are native to Minnesota. So I decided to simulate growing soybeans, and soybeans have 14 nutrients that they need to develop. And these include nitrogen, phosphorus, potassium, sulfur, calcium, magnesium, and more. And so from the soil, we already get most of those nutrients that I mentioned, but we still need nitrogen and phosphorus, and that's where the vermicompost and fertilizer can come in. So, and the nitrogen is needed to allow the plants to reach full height, and the phosphorus helps with growing roots and speeding up maturation along with winter hardiness, which is really important in Minnesota. So the best combination of organic materials to give to a vermicomposting bin would be mostly brown materials with maybe just a little bit of green to keep the moisture levels regulated, but mostly brown to add the nitrogen and back into the soil. Okay, limitations. The biggest limitation I had was time. Originally I had planned to grow plants and actually apply my fertilizer to it instead of just simulating it. So I would have applied like a few plants, given them like the fertilizer from the control group, and then a few of the fertilizer from the green group, and then from the brown group, and then I would have had one with no fertilizer, and then I would have grown them over a time period and then examined like how fast they were growing and any observations. And this would help me have more concrete conclusion and be able to like bring my simulation to like concrete data. The other limitation was I couldn't do very comprehensive testing just because it's expensive. I wish I could have tested for calcium and vitamins because those are both found in a lot of the green materials I used, but the kits, I couldn't find any kits that were in my price range that could handle them. This kit, for example, it tests for calcium, chlorides, iron, magnesium, manganese, sulfur, and more. And that would have been really helpful to, especially in the soybeans, because the soybeans also require a lot of those. but it was upwards of $700, so I couldn't find another one that was like more in my price range. So in my mock simulation, I was able to create organic material combination that would best fit the requirements for the system for the soybean plant growing in Minnesota. And this is important because understanding the impact that the organic material we give into our vermicomposting, we can specially curate organic fertilizer that specifically targets the depleted nutrients and allows the plants to grow more effectively.
How did your review of methods used by scholars in the field inform your selection of a research method that was aligned with your question?
So I did a lot of research on like the materials I was going to use, and that shaped like the way my research process went, because it like gave me the idea of what to test for, nitrogen, potassium, and phosphorus, because like I noticed that a lot of the green materials had a lot of potassium, and then a lot of the brown materials had nitrogen and phosphorus, and so that like based what I was going to test it on and like how I applied it to the soybeans.
Okay. How do your findings provide direction for future research?
So for future research, like I said, we could grow like my simulation, the soybeans, we could actually like do that and develop like real soybeans, and we can also like apply it to like a larger scale for farmers in Minnesota, like starting their own vermicomposting bins and knowing what materials to put into them based on what they're growing to more effectively like grow their crops.
Okay, what was the most important research skill you developed as a result of this process, and how might you apply it to your future endeavors?
Most important skill would probably be editing like my method, because I had to change what I was doing a lot of times. Like originally I was planning on testing for something else, and then I changed it when I did more research. So just having an open mind about like what your research questions are going to be, and like know it always changes.
Okay. Thank you. You can all that a huge round of applause or